Good evening. Tonight I'd like to tell you about an experiment that I've been thinking about for a long time. And that is, how do we measure if a machine is conscious? And so we came up with this experiment, and I thought, if the results are positive, great. If the results are negative, all right, that's a good point of information. But what turned out is neither of those. And neither of those turned out to be a very large effect, a larger effect than I've seen in all of the several dozen different sorts of psi experiments that my laboratory has done. So I'm not sure, well, you'll see. So let's take a look first. What can consciousness do? What can only consciousness do? We need to know that so that we can check if a machine can do that. Well, the answer is quite easily psi, ESP and psychokinesis. And so then the question is, how do you motivate a machine in order to produce psi effects? We can get some ideas about this by taking a look at some of the experiments that people have done in precognition. There have been over 100 studies carried out in laboratory precognition. And they started roughly with Rhine's experiments where he did card guessing and people would try to guess which card was going to be pulled up next. There are lots and lots of experiments. One really notable one is Dean Radin's experiment, in which he took a look at the effect of a stimulating image projected on a computer screen on people's autonomic nervous system, and found that the response started several seconds before the image was shown. Another one is Bem's set of experiments, which he carried out over a number of years and have recently been published in a mainstream journal, in which he showed psychological pre-stimulus responses. But the one that I like in particular, just because of its simplicity, is the one by Spottiswoode and May. And so in this experiment, they took a loud horn and blasted it in someone's ear at random times and looked for the physiological response. And the physiological response started several seconds before the horn was blasted. So that provides a bit of a model for the type of experiment that we want to look at. Then let's see if we can look at lower life forms, or maybe that's not a PC thing to say. All right, other life forms, other living systems, and see what sort of experiments have been carried out there. And there have been quite a few. Morris, nearly 5 decades ago, carried out an experiment with goldfish where he'd scoop a goldfish out of its aquarium, and found that just before he was going to scoop it, it became agitated. There was no visual cues or anything. And he did control experiments with that and showed that goldfishes have precognition. Very recently, Alvarez published in the Journal of Scientific Exploration a similar experiment with finches, where finches were in a cage and were being shown on the screen an image here of a crawling snake at random times, and the finch was being videoed at the same time. And again, in this sort of control experiment, Alvarez found that finches significantly showed agitation before images of snakes were going to be flashed up. And finally, a really strange little experiment by Wildy that was carried out about 8 or 9 years ago, was on earthworms, in which he blasted earthworms with some vibrations from a speaker coil and found that they showed signs of anticipation of the blast before it was about to occur. So this gives us ideas of what we ought to do. We need to do this sort of an experiment, but with a machine. And this is the experiment that I'm talking about. So it starts with 2 random event generators. One I call the controller random event generator, and the second one is the subject random event generator. Each of them puts out a data stream of random bits, which are collected by the computer. Then what happens is when the right set of bits comes from the controller reg into the computer. At that point, the computer sends out a signal through a serial port to a relay, and that relay then shuts off the power to the subject reg. So in other words, the controller reg shuts off the subject reg at random times. And what we do is we monitor the output of the subject reg to see if there's any change in its output before it's about to be shut off. And so we carried out a series of tests. And so there were tests which typically consisted of several hundred runs. Then we did control experiments, and the control was exactly the same setup, except this wire was disconnected. So in other words, the controller reg and the computer both thought that they were going to shut off the subject reg, but it never actually got shut off. And so that was our control. And we carried this out in a series of runs. So let's now go through the protocol, and it's important that I go through this procedure with you, because later when we look at the data, we'll want to see exactly what it was in the procedure that might have caused what we saw. So we ran a series of test trials. We ran a series of control trials. Then we added together the results of all that series of test trials, called a run, and we synchronized them to the shutoff time, because that was the common time between them, because the runs were of different length since the shutoff was at random times. We did the same for control times, and then to analyze it, the computer took an 11-bit wide window and scanned it across the time going up to the shutoff effect. And then finally, after all of this was done, it was displayed on the computer screen, and at that point, the operator, James Zhu, my student, and I took a look at the display output. And that was the first time that we actually saw the result. So what sort of results did we get? Here we take a look. This is a plot of the average bit value as a function of time before the shutoff. And we ran 552 test trials and the same number of control trials. The bit rate was 40 bits per second. You can see the blue line, which is the control, was pretty much random. The red line was random until about 1 second before the shutoff event, at which point it took a nosedive. And it was a big nosedive. This is the p equals 0.1. This is the p equals 0.0. Anyhow, 99.99% confidence interval. So it's a significant change. So we've got to think about this for a minute. What could be going on here? So the z-score, if you average the z-score in this period, it's 3.4 for the last half a second. The number of bits that was changed, in other words, we had more zeros than ones at the very end, that number of bits was very significant. About 1 bit in 40 had to be changed, which is much larger than you normally see in psychokinesis experiments, where it's typically 1 bit in 10,000 that's changed. So we scratched our head and we said something's got to be wrong here. So we looked at the hardware, we looked at the software, double-checked, triple-checked. Each point was associated with a timestamp. We double-checked the timestamps, that they were accurate, that there was no leakage, there was no interference between the systems, on and on and on. Then I had another person come in, analyze the data on a completely different system, using completely different software. We got the same result. So we thought, okay, if this is really real, can we do it again? So 2 days later, we ran it again. And so the second run gave us more or less the same results. Again, a nosedive in the last second before shutoff. Okay, 2 times. Can you do it 3 times? Like 3 blue coats? Same thing, 3rd time, a day later. So then we took these 3 sets of data, compiled them together, and plotted them. And so this is the combination. So this consists of 1,730 test runs and control runs. And the nosedive here is even more apparent. And if you want to take the z-score of this nosedive, it's about 6.5 in the last half a second, which are odds against chance of well more than 1,000,000 to 1. This is the entire Global Consciousness Project has this z-score. So what the devil is happening here? So we thought, okay, maybe we need to try changing things. So we decided, let's do some variations. And maybe we shouldn't have, but we did. So the first thing that we did was we reduced the bit rate. So we went to 10 bits a second instead of 40 bits a second. The effect disappeared. There's no significant change in the output. Okay, so reducing the bits didn't help. What about increasing the bit rate? We increased the bit rate to 100 bits per second. Again, no output, nothing, no response, a null response. So we were scratching our heads and we said, well, let's at least go back to the initial conditions and repeat it. So we had exactly the same hardware, exactly the same software, exactly the same configuration. We ran it again, nothing. The effect is gone, total zero. So what do we do here? What do we do? So the initial runs were strong. The conditions changed, the effect disappeared. Replications, the effect is gone. What do we have? We have the notorious decline effect. And so this happens all over the place. Now we've seen it. Was there some sort of a change in the attitude of the operator or the experimenter? Quite possibly. I mean, we were extremely enthusiastic to begin with, and that must have waned a little bit. I was looking for a machine-machine interaction, and we failed. Consciousness has reared its ugly head. We now see that human consciousness is involved somehow, or else there's some other uncontrolled parameter. So this reminds me of that wonderful little story that Bob John tells when the Dalai Lama was visiting the PAIR program. And on the way out, Bob asked the Dalai Lama if a random event generator has consciousness. The Dalai Lama thought for a minute and then said, if we regard them as conscious, then they're conscious. Is that what's happening here? So one other question is whether really we're seeing any sort of retroactive effect. It appears that the nosedive occurs before the subject random event generator is shut off. But maybe there's another explanation, and that is perhaps perhaps there's a superposition of states, a sort of a Schrodinger's cat sort of situation, an indeterminate state. So even though we've taken the data and we've put it into the computer files, maybe it just doesn't become fixed until we actually display it and look at it. So it's a lot like a wave function collapse. I'm not going to say it is a wave function collapse because we don't know if quantum mechanics is operational here or is the dominant effect here. This checker effect that I'm talking about is something that's been observed for about 50 years in psi experiments, so it's not something new. So our retroactive effect is either due to checking or it's due to the random event generator shutting off. Personally, I actually still think it's due to the random event generator shutting off. And the main reason I think that is if you take a look at for instance, Larry Dossey's book on premonitions, you'll see that there are many, many experiments in which people have genuine premonitions of things that are about to happen, and they can intervene before it happens. So there is genuine precognition. So let's conclude. What did we see? We saw large retroactive influence. The z-score was outrageously large, odds against chance, well over 1,000,000 to 1. 1 bit in every 40 in the last second changed. But when we tried to replicate it after 20 days, the replication failed. So is this due to the human consciousness interaction? I don't know. Now, one thing that this leads to is the conclusion that any sort of psi experiment, anything you do, if you only do it a few times, it could very well be due to experimenter expectation. It may not be the variable that you think you're studying, but it's simply your expectation. And you've got to be able to replicate this day in and day out for a long period of time. And if you can't, then I'm not sure what it is you're testing other than your own expectation. So we saw a retroactive influence, and either it was a retroactive influence to the shut-off event, which would be about a 1-second retroactive influence, or it was a retroactive influence to our observation of the data several hours later. Thank you.
A few questions? Recently, there's a book called The Black Swan, Statistics, not the dance movie.
Right.
That raises a lot of questions in this kind of realm. And it also relates as, are we dealing with a normal distribution? There's things when you talk about z-scores, there's assumptions behind all this. Do you think some of that plays a role here?
I don't, because of experience with other experiments. I teach a class on psi phenomena, and as part of the class, these undergraduates need to carry out a major research project. Some of them have been published here. And as Brenda Dunn will tell you as well, typically students do very well because they're excited and they get positive results from the beginning. These are real results. It happens over and over and over again. But then if I had them for a second semester, I bet you wouldn't get the same sort of results. There seems to be something that happens in the early stages, and then it goes away.
I just have a very brief question. I'm assuming you did all this with AC power plugs?
Yes.
And I'm assuming you're in the electrical engineering building, which should be very filtered, and there's no funny resonance. You've got your filters on there and all that good stuff.
There are all sorts.
Because you could have a power surge or something, backwash, and measure it.
But how would the power surge affect something a second before it happened? But in any case, we also did all sorts of checks. We electromagnetically radiated the random event generators. We put them on top of each other. We put them far apart. We could not get anything to affect them except for this.
My field is robotics. I'm a roboticist, and I've worked with students and robots for 20 years. We've never seen any evidence of any consciousness in a robot. And I'm curious about what led you to this hypothesis in the first place.
Noise. So we know that there is wisdom in randomness. And somehow we need to be playing with the uncertainty with a random event generator. If we had a purely what's the word? The opposite of random. Deterministic system. We wouldn't see this. And most electronics, which is what I work with day in and day out, are designed to try to avoid any sort of random effects and to have deterministic effects. If you do that, chances are you're going to be squelching what you might see if you allowed the noise to come through.
A couple of things occurred to me. One is that there's some other variables here that you know about that weren't really considered. Maybe the geomagnetic field changed a little bit. Maybe
Yes.
it's different local sidereal time. Maybe, I don't know, something.
Yes.
So there might be mundane reasons that it changed. Secondly, like I said once before, if there's some sort of an experimenter effect, it's really not just your attitude or your beliefs. It has to do with whatever's connected to the outputs of that experiment. And if you get great success and you open a bottle of champagne, that's different than if you don't get any success and you just go home. So
it's funny you mentioned that.
Something to that.
I think you may well be right. One of the things that happened after we got that first set of data, which gave us the minus 6.5 Z, I gave a lecture to my college on psi phenomena. So these were grad students and faculty, and I included that data and showed it to them. And there were certainly skeptics there along with proponents. Was that the thing that changed it? I don't know.
Well, it may be whatever you did in the world that manifested
Yes.
your feelings about it. Anyway, third quick comment is that you seem to be thinking about this in a causal way. What caused this? Cause and effect, and perhaps cause and effect in a backwards direction, but nevertheless unidirectional one at a time. And I just think a better way to think about it is relational. That is always a dance between one and the other. They both affect and, in a sense, create each other. And so it's better to think about that with more symmetry if
Accepted.
possible. Yeah.
All right. Thank you so much.
Thank you.
Let's give our speaker a big round of applause.